This time we will talk about what is the system curve and how we can use it to determine how much water is pumped. We will determine that by looking at the intersection of the pumping head capacity curve with the system characteristic curve. Let's start saying something that you may already know. The values that we can find in the plate of a pump, capacity or flow and head, are values from the maximum efficiency point. That does not mean that when working, the pump will be delivering that flow or that the pump will operate at that point. So, keeping that in mind, what flow does a pump really deliver? Now let's see. Here is the flow or capacity of pump, and here is the head. This one is the pump characteristic curve, head versus capacity. We have a pumping system, suction line, the pump. Here is the head flow characteristic curve of the pump. The pump is pumping the water to a tank. The total pump dynamic head or the pumping head would be the static or geodetic head plus the head losses. What is the static or geodetic head? It is the elevation difference between the water level here and the discharge point. For the water level at the intake, we take the minimum level of water because the water level fluctuates. This one is the geodetic head or static head that the pump must overcome. So that's the minimum head or pressure even for a zero flow. Let's see the procedure to calculate or to find the system curve. Suppose here we have a valve. Normally at the discharge of pumps we have always a valve. At the beginning the valve is closed. We start the pump with closed valve at the discharge. So here we have zero flow. The pump started working at this point. That is zero flow and the pressure indicated by the manometer. A manometer that is installed here tells us that the pressure in meter is this value, about 90 meters. Then we open up the valve a little until 10 liters per second. The water starts to flow. And the water, when begins to flow, generates head losses due to the flow resistance in the pipes, valves, and fittings. For that flow rate value, then we will calculate losses. To calculate the head losses, we can use a formula that can be used for water, the Williams formula. In another video, we will explain more about the Williams formula and will tell you how to use a free app to calculate the head losses. Do not forget to subscribe below, please. Then, increasing the flow rate, we calculate the head losses for the different values of flow rate. These losses are added to this value, which is constant. That is the static head, and doing that we obtain the total head, or total dynamic head, for the different data and flow rate. These values are going to be, of course, above the static head. For 10 liters per second we get a value that would be this. For 20 liters per second we have a higher value. As the flow rate increases, certainly the losses also increases because friction losses are greater. The friction losses are proportional to the flow rate. So we can build a curve that is called the system curve, which grows with the flow rate. Where the system curve intersects with the head curve of the pump, this point is precisely what is called the working point and shows the flow rate that the pumps deliver and the head that is going to develop. This is the working point. Let's assume 75 meters and 35 liters per second. This could really be the flow that the pump delivers. It probably does not match the flow that is written on the plate. The flow you have in plate is the point of maximum efficiency, but here we are displaced a little. The efficiency here is a little lower. If we want to move the system curve, we have to increase the losses. There are better ways, so that the pump could work on a zone of maximum efficiency. We have to shift this curve down to intersect it with this one. We do that with a variable frequency drive or by cutting the diameter of the impeller. We will deal with that in another video tutorial. Or we can do it by closing a little the valve, increasing losses in this element, in this accessory, increasing losses in the valve by closing it. We raise the curve so that it goes through this point. But that's not today's goal of this video. What we wanted to show is that the flow a pump delivers is determined from the result of intercepting the pump performance head curve with the system curve. I thank everyone for watching our video. Hope you have liked this video and we say goodbye until next video.